Hello friends, I had promised you that we are going to have a part 2 on area of triangles. So in this video, I'm going to tell you two more important methods to find the area of triangles. This involves trigonometry. So let's get started. So we are going to find the area of triangle using trigonometry. So what is trigonometry? Trigonometry is a branch of mathematics that studies relationships between the length of sides and angles of a triangle. So it is all about triangles. Trigonometry. Know sides, we can find an angle, and if we know an angle and a side, we can find the other side. For this purpose, we must convert a triangle into a right angle triangle. Yeah, a right angle triangle, and use a trigonometric function. A trigonometric function is a ratio between the sides of a right angle triangle. There are three trigonometric functions. Those are sine, cosine and tangent. We will be using only sine function to find the area of a triangle. Sine of an angle. So the sine function is defined as the ratio of the opposite side of an angle to the hypotenuse. So let's take this right angle triangle as an example. So if we take angle A, the opposite side is side BC and the hypotenuse is the opposite side to the right angle. So the sine function of angle A is opposite side by hypotenuse equal to A by C. It is very important that side A is the side opposite to angle A. Side B is the side opposite to angle B, and side C is the side opposite to angle C. So I'm going to mention this a lot of times, and it is throughout this video this will be applicable. A ready table is available for sine of various angles, like the sine of all the angles are fixed. The ratios are always constant. Therefore, knowing sine of an angle, we can always find the ratios of the sides. In other words, knowing one side and sine of an angle, we can find the other side. So finally we have come to method 6, finding the area of triangle using the sine function. Consider the adjoining figure, this figure, the right angle triangle. The area of this triangle, as we know, is half into base into height. So here also we can see that side A is opposite to angle A, side B is opposite to angle B, and side C is opposite to angle C. In this triangle, the base is B and the height is A. Assume that we know B and C, but we do not know A. We do not know the height, but we know the base and the hypotenuse. If we know angle A, angle BAC, then sine of angle A is equal to opposite side by the hypotenuse, is A by C. So if we equate it, like if we transpose the C to the other side A will be equal to C into sine A. So the height is basically C into sine A. So as we know the height, the area of triangle is half into B into C into sine A. Without knowing the height, we have calculated the area of triangle using the sine function. We took the sine of angle A, then multiplied by C, B and half. So this is the method 6. Converting any triangle into a right angle triangle. As we know that trigonometric functions can be only used in a right angle triangle, we have to convert other triangles into a right angle triangle. So area of any triangle we can take as half into base into height. Sine function can only be used in a right angle triangle. The technique is to find the area of any triangle is to convert it into a right angle triangle by drawing a perpendicular and use the sine function to calculate the unknown sides. So basically we are going to draw a perpendicular. So let's take the first figure, triangle ABC. Then we are going to draw a height h, which is perpendicular. So this is an acute angle triangle, and then we drew a height h. Now due to this we can use the sine function and calculate the area of the triangle if we know the sides and angles. Then it's an obtuse angle triangle, figure 2, triangle ABC. Here also we drew a height from C to side AB, and then if we know the sides and angles we can find the area of triangle using the sine function. Now figure 3, an acute angle triangle or maybe isosceles triangle. So here also we draw a perpendicular height from vertex B to side CA, and then if you know the sides and angles we can find the area of the triangle using sine function. Let's take an example so that everything is clear. Let's take right angle triangle ABC. AB is equal to 6 cm, which is the height. BC is equal to 8 cm, which is the base, and AC is equal to 10 cm, which is the hypotenuse. And angle C, angle ACB, is equal to 37 degrees. Now the first method is the most basic method. Area of triangle is equal to half into base into height. This half into 8 into 6. The base is 8, the height is 6. 8 into 6 and 24 square. Now the method 2 is using the sine function. So as we know that the area of triangle ABC using sine function is half into AC into BC into sine C. So in this, the sides enclosing an angle, if we multiply them and multiply it with the angle they are forming, multiply it with the sine of the angle they are forming, and multiply it with half, we can find the area of the triangle. So in this case, the sides enclosing are 10 and 8 cm, and the angle C is 37 degrees. So half into 10 into 8 into sine 37. So sine 37 is approximately 0.6. So we can tell that half into 10 into 8 into sine 37 is half into 10 into 8 is 0.6. So in this method too, you can see that we are not using the height yet. So directly we have got the answer 24 cm square, which matches with the method 1. So in case we do not know the height AB 6 cm, so we can still calculate the area of triangle using the trigonometric function sine. Now the law of sines, finding the area by method 1. So first we will take a triangle and then I will show you the law of sines. So this is the triangle ABC. As you can see, angle A is opposite to side A, side B is opposite to angle B, and side C is opposite to angle C. There is a perpendicular height drawn from vertex C to side BA, and angle B is marked. So area of triangle ABC is half into base into height, half into C into H. The C side is BA is the base and H is the height. So the point D is the end of the perpendicular. Now sine B, as you can see, angle B, sine B is equal to opposite side by the hypotenuse. So the opposite side is the height of the triangle, which is H, and the hypotenuse is the A. So we are considering triangle CBD here. Because trigonometric functions can be only used in right angle triangle, we are considering right angle triangle BCD here. And for sine B, the sine B is equal to the opposite side, which is H, and the hypotenuse, which is A. Now, if we transpose A to the other side, we get the value of H as A into sine B. Therefore, if we substitute H in the formula half into base into height, we get area of triangle as half into C into A into sine B. Half into C into A into sine B. This half into AC into sine B. So, one of the methods to find the area of triangle using trigonometry is this. Now, law of sines, finding the area by method 2. Now this is the same triangle, but now we have drawn the perpendicular from vertex B to side CA. Now the area of triangle still remains half into base into height. This is half into B into H. B is the base and H is the height. So D is the end of the perpendicular. Now sine C, angle C is marked, so sine C is equal to the opposite side H upon hypotenuse A. So we are considering triangle CBD here. So as it is a right angle triangle, trigonometric functions can be used. So sine C is opposite side, which is H, and the hypotenuse, which is A, H by A. Now if we transpose A to the other side, we get the height as A into sine C. So here also we substitute for H. We get the area of triangle ABC as half into B into A into sine C, half into AB into sine C. Law of sines, finding the area by method 3. So now it is the same triangle. We have drawn the perpendicular from vertex B to side AC, but we have marked the angle A. So the area of triangle ABC is half into base into height, is half into H into B. The point D is marked. Now sine A, sine of angle A is opposite side by the hypotenuse, is H by C. We are considering triangle BDA. So as it is a right angle triangle, trigonometric functions used, and sine of angle A is opposite side, which is H, the hypotenuse, which is C, H upon C. Now we transpose C to the other side and we get the height as C into sine A. So here also we substitute for H, we get area of triangle ABC is half into C into sine A into B, half into BC into sine A. Now the main formula of law of sines. This is the same triangle. We have found that the area of this triangle can be written as half into AC into sine B, or half into AB into sine C, or half into BC into sine A. So these all areas are equal. As the triangle is the same, the areas are equal. So we can tell that AC sine B is equal to AB sine C equal to BC sine A. So the half is being cancelled or cut. So if we divide all the three sides by ABC, so AC sine B divided by ABC, AB sine C divided by ABC, BC sine A divided by ABC, we get sine A by A equal to sine B by B equal to sine C by C. This is the law of sines. So in many places, law of sines can be also written as A by sin A equal to B by sin B equal to C by sin C, but it's just the reciprocal. So this is the law of sines. Now the method 7, finding the area by another formula. This involves the law of sines. So the area of triangle ABC is equal to A, which is the area, a half into AB sin C. So instead of half, I've just divided the whole thing by 2. AB sin C by 2 is equal to AC sin B by 2 equal to BC sin A by 2. You have seen the triangle. So this area of the same triangle can be written in 3 forms. Now if we take the inverse, which is the reciprocal of it, so the area is A. So if we take 1 by A, we get the area as 2 by AB sin C equal to 2 by AC sin B equal to 2 by BC sin A. To multiply all the 3 by ABC by 2, ABC by 2, so that we can remove the 2. You can see the 2 in the numerator. If we want to remove it, we will multiply it by ABC by 2 throughout. So 1 by A into ABC by 2, 2 by AB sin C into ABC by 2, 2 by AC sin B into ABC by 2, and 2 by BC sin A into ABC by 2 will multiply, and we will get ABC by 2A, 2 times the area, is equal to C by sin A equal to C by sin B equal to A by sin A. So if we take B by sin B and A by sin A, we get B. So we are just transposing sin B to the other side. We get B as A into sin B by sin A. So now we are just substituting into the formula, half into AB into sin C. We get the area as half into A sin B. We just replace B by A sin B by A sin B by A into sin C. So we get half into A square sin B by sin A to sin C. So in this formula we have used the 3 angles on one side. Side angle A, angle B, angle C, and side A. So method 7, half into A square into sin B by sin A into sin C. So there are various possibilities of finding the area of triangle, such as there are 3 sides are known and you have to find the area of triangle. 2 sides and an angle is known, you have to find the area of triangle. 2 sides and an enclosed angle known, you have to find the area. 2 angles and a side known, you have to find the area. 2 angles, a common side known, find the area, and the 3 angles known. So 3 sides known, we call it as SSS. 2 sides and an angle known, we call it as SSA. 2 sides and an enclosed angle known, we call it as SAS. 2 angles and the side known, we call it as AAS. 2 angles, a common side known, we call it as ASA. 3 angles known, we call it as AAA. Area of triangle SSS. These 3 sides are given. So SSS means all the sides are given: side BC, side AB, and side CA. So AB is 6 cm, BC is 4.7 cm, and CA is 6.2 cm. So in this, when 3 sides are given, we use the Heron formula, where S semi-perimeter or the half perimeter of the triangle. So we put S in the formula, square root of S into S minus A into S minus B into S minus. For more details, please check out my previous video on area of triangles part 1. So after we equate and calculate the area, we get the area as 13.2 centimeter square. Now area of triangle SSA, where two sides and an angle is given. So here you can see that side, side and angle is given. Side, side, angle. SSA. The order SSA, side, side and an angle is given. So here we use the law of sine. Sine A by A is equal to sine by B, sine B by C to find the additional angle, and then we find the height using the sine of the angle. So first we'll use the law of sines. Sine 45 on 4.7. So side A is opposite to angle A. Side A is 4.7 centimeter is just opposite to angle A. So now sin A by A, which is sin 45 by 4.7, equal to sin C. We'll see sin C by 6. So 6 centimeter or the side BA is C, is opposite to angle C. So if we transpose 6 to the other side, we get sin C equal to 0.9027. Now there is another function called as sine inverse. That's the opposite function of sine. For example, sine 90 is 1. Sine inverse of 1 is 90. So sine inverse of 0.9027 is equal to 65 degrees approx. Got angle C as 65 degrees. Now we use the angle sum property to find angle B, which is 70 degrees. Now we draw the height H. Now we are going to consider triangle BCD. So D is this point. Now sine B, sine 70 is opposite side is CDH by 4.7 centimeter, which is A. So H by A, which is H by 4.7. So if we transpose 4.7 to the other side, we get 4.7 into sine B, which is 4.7 into sine 70 degrees. Sine 70 is 0.9397. So we get the height as 4.42 centimeter. Now as we got the height, we can find the area of triangle by the formula half into base into height equal to half into 6 into 4.42 equal to 13.3 centimeter square. So area of triangle SAS, where two sides and an enclosed angle is given. So let's take the same triangle EBC. So side, angle, side. So side AB, angle A and side CA is given, where the angle A is enclosed by the arms of the angle BA and CA. So BA is 6 centimeter, CA is 6.2 centimeter and the angle A is 45 degrees. Now we draw the height, the perpendicular from vertex C to side BA. Sine of angle A is the opposite side, which is H upon 6.2 centimeter. So here we are just considering triangle ACD. So D, the point here, it is the intersection point of the perpendicular H to the side BA. We are considering triangle ACD, where the sine of angle A 45 degrees, H opposite side by the hypotenuse 6 by 2 centimeter. So h by 6.2 centimeter is sine A. So if we transpose 6.2 centimeter to the other side, get h as 6.2 to sine A is equal to 6.2 into sine 45. Sine 45 is 0.7071. So with the height as 4.38 centimeter. The area of triangle is half into base into height, and since we know the height, we can just find the area of the triangle by using this formula as half into 6 into 4.38 equal to 13.2 centimeter square. So whenever two sides and an enclosed angle is given, you can directly calculate the area as half into BC into sin A as we saw earlier. So you can just write it as half into 6 into 6.2 into 45 degrees. So sin 45, half into 6.2 into 6 to 0.7071 sin 45. We get the area as 13.2 centimeter square. We use both the method, but we got the same answer. Area of triangle AAS. Two angles and a side is given. So we now have angle A, C and side BC. Angle, angle, side. From the same order, AAS, angle, angle, side. So now first we use the angle sum property of a triangle which is 180 degrees, and then we find the angle B as 70 degrees. Then we use the law of sines, find the opposite side to angle C. Angle C is 65 degrees. The opposite side to angle C is C. We are going to find this C. For that, we use the law of sines. Sine of angle A, which is 45, upon 4.7, which is side A, is equal to sine of angle C, which is 65 degrees, upon C, on side C. So if we transpose, then we get side C as 4.7 into sine 65 by sine 45. 4.7 into 0.9063 upon 0.7071, which is 6 centimeter approx. So C is 6 centimeter. Whenever two sides and an enclosed angle is given, you can directly calculate the area as half into AC into sine B. So we know side BC and side BA and an enclosed angle B. So we can directly find the area as half into 4.7 into 6 into sine 70. Half into 4.7 into 6 into 0.9397 equal to 13.2 centimeter square. Area of triangle when two angles, the common side is given. So angle, side, angle. So angles sharing a same side. So angle B 70 degrees, angle side BA 6 centimeter, angle A 45 degrees. Now we have to find the area of this triangle. So we find the third angle, angle C, which is 65 degrees, by using the sum of angles property. Then we use the law of sines to find the opposite side to angle B. So the law of sines is that sine of C upon C is equal to sine of B upon side B. So C is opposite to angle B is opposite to angle B. So sine 65 by 6 equal to sine 70 by B. So if we transpose, we get B as 6 into sine 70 by sine 65 equal to 6 into 0.9397 on 0.9063. We get B as 6.2 centimeter approx. Now whenever two sides and an enclosed angle is given, we can use the formula half into BC into sin A to calculate the area directly. So side AC, AB is given. These are the arms of angle A, so we can directly find the area as half into 0.2 into 6 to sine 45 is equal to half into 0.2 into 6 into 0.7071. We get the area as 13.2 centimeter. Now the area of triangle when three angles are given AAA. So we have got the same triangle, triangle ABC. So there are do not know any of the sides. Therefore, the length of the sides can range to infinity. So we cannot determine how long will be the sides. So when we do not know the length of, we do not know anything about the sides, the area of this such a triangle cannot be calculated. So AAA, where three angles are given, we cannot calculate the area without knowing anything about the sides. So application in finding the area of other regular polygons. So we have found seven methods to find the area of triangles. We are going to use all these methods to find the area of other regular polygons. So first, the square. The square has equal sides, and if we draw a diagonal, we can divide the square into two triangles. So the area of square can be written as 2 into area of right triangles. So 2 into half into base into height. So the base is 8 centimeter, the height is also 8 centimeter. So half into 8 into 8 equal to 64 centimeter square. If we use the area of the square as side square, is 8 into 8, we get 64 centimeter, and this matches with our answer. So rectangle. So as we know, a rectangle has a length and a breadth. Here the length is 10 centimeter and the breadth is 8 centimeter. Draw a diagonal dividing the rectangle into two right triangles. So the area of the rectangle is 2 into the area of the right triangles. As the right triangles are equal, we can just multiply it by 2 to get the area of the rectangle. So it is equal to 2 into half into base into height. Area of triangles is half into base into height. 2 into half into 10 into 8. The base is 10 and the height is 8. So get the answer as 80 centimeter square. You can match this with the answer by using the formula of area of a rectangle, which is length into breadth, 8 into 10, which is 80 square. Now a parallelogram. Parallelogram. So we draw two perpendiculars from in the parallelogram, dividing it into two right triangles and a rectangle. So these two right triangles are equal. So the rectangle which is in the center, we can divide it into two right triangles by drawing a diagonal. We get four right triangles. Two small right triangles are equal and two large triangles are equal. The area of parallelogram is base into height. So you can draw the two perpendiculars, convert the parallelogram to right triangles and rectangle. Then you also draw a diagonal and calculate the area of two congruent triangles and multiply the area of each triangle by 2 and get the area of the parallelogram. Rhombus. As you know, rhombus has equal sides and diagonals of the rhombus are perpendicular bisectors. So when we draw the diagonals of the rhombus, they bisect each other, forming four congruent right triangles. So we just multiply the area of one right triangle by 4 to get the area of the rhombus. You can match this with the area of the rhombus, which is half into d1 into d2, where d1 and d2 are the diagonals of the rhombus. Trapezium. So here's a trapezium. We are drawing two perpendiculars, dividing the trapezium into two congruent right triangles and a rectangle. Now we draw a diagonal, dividing the rectangle into two congruent triangles. So here we are getting the trapezium divided into two smaller congruent triangles and two larger congruent triangles. We then multiply the area of each triangle by 2. So we calculate the area of one smaller triangle multiplied by 2. We find the area of one larger triangle multiplied by 2 and add this area to get the area of the trapezium. You can match this with the area with the direct formula to find the area of trapezium, half sum of sides to height. Kite. So in a kite, when we draw the two diagonals, the longer diagonal is the perpendicular bisector of the shorter diagonal. As the diagonals of the kite are perpendicular, we can convert a kite into four right triangles. Then we find the areas of the smaller and the larger right triangles. So basically, the smaller triangles of the kite are congruent and the larger triangles of the kite are congruent. Finally, we add the areas of the four triangles, get the area of the kite. This matches with the direct formula to find the area of a kite, that is half into d1 into d2, where d1 and d2 are the diagonals of the kite. A regular hexagon. So, regular hexagon, all the sides are equal. So, when we draw the three diagonals, dividing the hexagon into six equilateral triangles, we can find the area of each equilateral triangle. As we know that the area of each equilateral triangle is root 3 by 4 a square. You can check out my previous video on area of triangles where I have explained in detail the area of an equilateral triangle. So for finding the area of a regular hexagon, we multiply the area of one equilateral triangle into 6. So we find the area of a regular hexagon as 3 root 3 by 2 a square. Thank you.